This is October, November 2022, 42 variant question. Question number 2. First part A. Define specific heat capacity. This question carries 2 marks. The answer is specific capacity is defined as the thermal or heat energy needed by per unit mass of a substance for per unit change in temperature. Then in part B, a fixed mass of water in a beaker is at atmospheric pressure. The initial temperature of the water is 0 degrees Celsius. The water is supplied with thermal energy E so that its temperature increases to 8 degrees Celsius. There's no net change in the volume of the water. Use the first law of thermodynamics to complete table 2.1 for this process. This is table 2.1. This is given to you. The thermal energy supplied to the water is E because the question mentioned it. The water is supplied with thermal energy E. That's why it's plus E. This question carries 2 marks. 1 mark for this, 1 mark for this. The work done on the water is 0 because the question says there's no net change in the volume of the water. The formula to find work done is equal to P times delta V. Since your delta V is 0, the work done is 0. Then to calculate the increase in internal energy, we use the first law of thermodynamics. Delta U equals to Q plus W. Delta U equals to E plus 0 because your W is 0. So your delta U is E. That's why how you get 1 mark here. In part 2, the water is now heated so that its temperature increases by a further 8 degrees Celsius to a final temperature of 16 degrees Celsius. This process causes the volume of the water to increase so that work is done. Assume that the change in internal energy is the same. So that means your increase in internal energy is also plus E. Then the work done will be negative because the volume of the water increases. That means the water expands. So the work done is negative. So these two will carry 1 mark. This question is a 2-mark question. The way to get the 2 marks is given here. Work done correct minus W, and the increase in internal energy also correct plus E. So these two carry 1 mark. Then the second mark comes from your first law of thermodynamics. The thermal energy need to be calculated using the first law of thermodynamics, which is your delta U equals to Q plus W. Your E is the increase in internal energy equals to Q, we don't know, minus W. So your Q equals to E plus W. That's why your E plus W, because your work done is minus W here. When you bring over, it's plus W. Then for part C, use the information in part B to suggest with the reason how the average specific capacity of water between 8 degrees Celsius and 16 degrees Celsius compares with its average value between 0 degrees Celsius and 8 degrees Celsius. The answer is that more thermal energy is needed, so the specific capacity is greater. More energy needed because E plus W is larger than just E alone. This is the energy supplied to the water. This is a summary of the facts that you must know to solve this problem. Number 1, you must be able to define specific heat capacity. Number 2, you must be able to recall and use W equals to P times delta V. Know that your W is positive when work is done on the gas. This happens when the gas is compressed, causing the volume of the gas to decrease. W is negative when work is done by the gas. This happens when the gas expands, causing the volume of the gas to increase. Then you must be able to recall and use the first law of thermodynamics, which is delta U equals to Q plus W.